So I'm going to do an organic presentation. So this is my third time speaking, right? I spoke last year in May. The vein of the conversation is going to be very similar, but I'm actually going to get much more technical. So those of you who have been here for the previous presentations, we're going to go through 3 demonstrations of unified namespace. One is a flexible packaging company manufacturer. The second one is going to be a demo unified namespace that we use in Mastermind. Where we teach students how to do the architecture that we use for our clients. And then number 3, we're going to show you the unified namespace that we use for our 2 companies, the 2 companies that are actually represented here. So we have 4.0 Solutions here, and we have Intellic Integration. I own both of those companies. They are 2 of 50 companies that are in my portfolio. I am a controls engineer by trade. I've been in the industry 25 years. I spent the first 12 years of my career working for manufacturers on the plant floor. So electrician, mechanic, and then engineer. My best friends in the plant were operators. And this is an interesting thing. A lot of people will reach out to me and ask me like, hey, I want to get involved in digital transformation for manufacturers. And I say, well, what is your experience in manufacturing? Like, do you know how manufacturing actually works? Have you spent any time on the plant floor at all? I mean, did you just come straight out of college and you went to the carpeted side of the business and you've been in a cubicle your whole career? If so, you're going to fail. I mean, there's just no chance you can be successful in the 4th and 5th industrial revolution with manufacturers if you have no manufacturing experience at all. I mean, it's just not possible. It's literally impossible. There's no edge case. And the reason why there's no edge case is because every manufacturer's problem is unique, and it's a function of the way that they operate. And anybody here, Shannon, I know, does a lot with manufacturers. Anybody who has experience in manufacturing understands that there's no such thing as manufacturing. There's no object called manufacturer. Every single plant is different. Every process is different. There is no such thing. There are no 2 processes that are exactly identical. None. 0. They're a fingerprint. Every single machine is a fingerprint. Every cell is a fingerprint. Even if they're made by the Japanese, which are the most congruent processes in the world, they are all different, every single cell. Create a welding cell in the same manufacturing facility in Japan and they ship it to the United States to do welding. They produce 1,000 of them. They have 1,000 different cells. There will be unique attributes on every single cell, whether it's a tag that exists here but doesn't exist here, a different instrument here that doesn't exist there. Every single one of them are different. And if by chance those 2 cells are exactly the same when they're landed on the plant floor for site acceptance test and functional acceptance testing, as soon as site acceptance testing and functional acceptance testing is done, they'll be different, because you will engineer around some problem you run into while you're going through your site acceptance test. So if what I just told you is all Chinese, that is, everything I just said makes absolutely no sense to you, it won't matter for this conversation. But for those of you who do have manufacturing experience, I assure you, you all agree with me. I don't have any doubt that you all agree with me, okay? Another thing, how many of you are in business development? Like you're doing business development in some way, shape, or form. All right, so somebody asked me the other day, totally, I wasn't gonna mention this, but I started thinking of business development people go to networking events. So somebody sent me a message the other day and asked me this question. They said, hey Walker, have you noticed that business development has changed in the digital age? Nobody picks up their phone anymore. My call list is useless. No one picks up the phone, no one returns the call, no one reads the email. Do you have any thoughts on the future of business development? Yeah.
I'll counter that. It's a question of perseverance. It may take 18 to 25 touches to get that connection done, but there's no way around it. But Microsoft did some research on that, and they found out it's about 20 touches average before they can get through. Now, I'm not saying there's not other channels,
yeah,
but that call, I agree with what the person said, but it's a question of staying in it, and the only amount of people staying is only about 5% will continue to not give up.
I would say this. When we first started in 2015, Intellic Integration, which is our engineering arm, and then 4.0 Solutions is our education and outreach. Okay, so the things that are referenced up here are Intellic and 4.0 solutions. When we started in 2015, when John came into my garage in 2015, and he wrote up on the whiteboard what our business development strategy would be to scale Intellic integration. Okay, and we're all sitting in fold-out chairs. I think there's 8 of us, and he's sketching how we're going to sell systems integration as a brand new systems integrator. John came up with a strategy that was 1/3, 1/3, 1/3 based on 8 strategic accounts. Okay, so our goal was the top of our funnel was going to be 1/3 client referral, 1/3 vendor referral, and 1/3 cold. Okay, completely cold. Today it is 100% inbound. So in 2015, we were 1/3, 1/3, 1/3. Today we are 100% inbound. How many cold calls do you make in a day? People you just completely ice cold, they've not emailed us, they haven't reached out to us? None. Stephanie is one of our business development. John, how many stone cold? John's the senior guy. He's retiring in December. He's been doing this for over 30 years. How many cold calls do you make in a day, John?
You put me on the spot.
I'm putting you on the spot. Ice cold calls, ice cold. 2 cold calls a day. In the old days, it used to be 100 cold calls would yield you 10 returns. 10 returns would get you 1 meeting. 10 meetings would get you 1 PO. That was the multiplier. Today, you could do 10,000 cold calls before you got to 1 purchase order. Okay, so for those of you who are in business development, okay, the traditional way of business development, how did we get to 100% inbound? 100%. Every single day, and actually I should show the chart if somebody wants to bring it up. You can show our leads. Every day, every single day, we end up with somewhere between 8 and 16 warm inbound leads that come into our business development team. And our business development team is made up of 3, right? We have 3 people, okay? We do the revenue. We have 20, we just had another, Intellic Integration has 27 employees, whatever, give or take. We do the revenue of an integrator that has 100 employees. And the reason I know is because I worked for 2 integrators at 100 employees, and we do the exact same revenue they did. And we do it with 27 people. And our business development staff is 3 people. And it's all inbound, every bit of it. So for those of you who are in business development, the answer to your question is no one's going to buy from you unless you're an expert. The customer is too savvy. The ignorant fools that number is getting smaller and smaller and smaller. You must demonstrate expertise to the market, and then they will reach out to you. I tell my team all the time, we don't sell shit. I don't sell anything. You will never hear me ask for the close, ever. You will never hear any of our team ask for the close, ever. Our team is focused on figuring out what the problem is and then demonstrating that we know how to solve it. And you know you have the sale when the customer says, what? What is the thing? We're waiting.
What are the next steps?
What are the next steps? You never, I would fire, if John said, hey, let's get a deal. Do you think we could get a deal closed today? I'd fucking fire him in a heartbeat. I would fire him in a heartbeat. Because it means he didn't do his job right. What he should have done was asked about their problem and then put him in touch with the person who can solve it. And when the client says, what are the next steps, the deal is closed. And all of that's done through digital media, by the way. All right, so the way you can find us, what we're known for, and why anyone listens to us, is because we went on YouTube in 2018, 3 years into this venture, and we realized, every single manufacturer is making the same mistake in digital transformation. Like they're literally the same mistakes. No one's doing it right. The only people who are doing it right are the companies who started after the year 2000. Everybody who's existed before 2000, and it's hubris. It's just hubris. It's all it is. It's like we've been around forever. GE and Predix. I mean, Jeff Immelt should be tarred and feathered. The level of his hubris. He was exactly the wrong person to lead GE. He drove them off a fucking cliff because of hubris. He believed that digital could be owned by a company. You mentioned Microsoft. They should be tarred and feathered. They believe that they can own digital. The OPC Foundation believes that they can own digital. Rockwell Automation believes they can own digital. PTC thinks that they can own digital. They cannot. No one owns it. Digital transformation, the fourth industrial revolution, is turning every single thing, every object in a business, every human being into a business, into a digital artifact, and connecting them all together on common technology. Today, what we're going to talk about is unified namespace, this architecture that I've been using my whole career to solve problems. And the reason we're talking about it and why we're talking about it en masse is because Microsoft's adopted it after they laid off 10,000 people. Eric Barnstedt, if you're watching, you should be fired. You cost 10,000 people their jobs because of hubris. Microsoft cannot own the stack. Rockwell cannot own the stack. In June of last year, Gartner, who I have no respect for, released a paper about unified namespace. And everyone read the paper and said, what is this unified namespace thing? And they started Googling unified namespace. And if you Google unified namespace, there's a name that comes up. And that name is mine. Because it's the architecture I created in 2005 in a salt mine using dynamic data exchange and Excel. Not DDE.net either. Not DDE.net. Unified namespace is an infrastructure. It is an architecture upon which businesses solve their problems. I'm going to show you today how that works, but we're going to start quickly on the digital transformation piece. Actually, I'm going to start with a LinkedIn post. So this is kind of what we're known for, but today this guy, and Andreas Vogler, posted on LinkedIn. He works for Siemens, and Andreas said, who here is familiar with OPC UA? Okay, so half of you. Anybody know who the OPC Foundation is? Okay, let's quickly figure out where everybody is. Who here, quickly tell me what industries you're in. What do you do? If you don't know the OPC Foundation, then you're not predominantly in manufacturing. So what are you in? What are you in? What do you do?
Telecom.
You're in telecom, and you do what in telecom?
PLM deployments.
Product lifecycle management, software deployments?
Software deployments just for telcos.
Just for telecom, okay.
Walker, there's going to be a lot of telecom people.
Yeah, what do you do?
Smart buildings, agriculture solutions.
So you do like building automation, that kind of stuff?
Yeah.
Okay.
Like IoT for buildings, IoT for agriculture.
Okay. All right. So the OPC Foundation, by the way, IoT and IIoT are two different things. Okay. IoT, the Internet of Things, is all of our cell phones connected together. Okay. It's all the smart things in our business, our thermostat, et cetera, et cetera, et cetera. And IIoT is the industrial Internet of Things. It's all of the industrial hardware connected together. But it's not industrial hardware connected together in one manufacturer. It is all industrial hardware connected together. Who here has seen me speak before? Okay, so maybe a third. I've done this thing, why is Tesla awesome or why is Amazon awesome? Okay, and if you've heard this already, please don't answer, okay? So why does everybody agree Tesla's awesome? Why are they awesome? You nodded your head yes. Why is Tesla awesome?
Because they're so far ahead of the curve, and they have been for a long time. And they have, I won't say perfected, but they have taken much greater leaps and bounds in their manufacturing process than the other manufacturers in the automotive industry.
Okay. What's your name and what do you do?
My name is Phil Kennewell. I actually work for HiBite.
You work for HiBite?
Yeah.
Okay, so the HiBite Intelligence Hub, okay, which actually I'm going to show you HiBite. We're actually going to demo HiBite here, okay, in our UNS infrastructure. So HiBite, for those of you that don't know, HiBite Intelligence Hub is a platform for doing data operations, which is one of the fundamental elements of digital transformation, whether it's for telecom or whether it's for manufacturers. Okay, HiBite is a platform that was built by the people who built one of the OPC servers called Kep server. Tony Payne, who helped build Kepware into Kep server EX, now leads the HiByte team, and it is a data ops platform. And it basically takes data, raw data from many, many different sources, and allows us to model it and then trigger it, an event, and drive it to some destination, okay? And it supports unified namespace. In fact, I'm gonna show the UNS client in HiByte today, okay? Why else is Tesla awesome? Anybody else tell me why Tesla's awesome? He cited manufacturing, which Elon will say is their primary value. Like, we've just gotten, we built Gigafactory and we're really good at manufacturing cars, and it's hard, but we've gotten really good at it. But yeah.
It seems like they do a better job of integrating everything together. So there's one central CPU as opposed to having like 100 of them in the car.
Okay.
So they do. They're really more of a software company than traditional car. manufacturing.
Agreed. They're a data company. The reason Tesla is awesome is because they're a data company. Like, manufacturing cars is not even their point. Like, most people don't know it. Like, I don't know how many Teslas are. I did look. There were 6 when I came in. There's probably 10 out there right now. Okay. Do you know what they manufacture? The most expensive IoT sensor in the world. And they collect data from all of us: human behavior, potholes on the road, stop signs that have tree limbs in the way, lights that aren't cycling correctly. Go to Boston. If you look at some of the data that Tesla is selling to in Boston, they're literally selling the data on how they should re-engineer the roads in Boston. I mean, most people don't know it, but Tesla doesn't give a fuck about the car. They don't care about the car at all. It's data. It's data. How many of you have access to every single data point you need, all the data you need, or any report you need, or any piece of information you need to do your job at the snap of a fingers in your employer, wherever you work? How many of you have access to everything you need at the snap of a finger? Nobody.
Neither one.
What's that? What's that?
What's the difference between neither one?
Well, it doesn't. Well, is there a difference?
Sometimes, yes.
Who decides what you need? Why would you want something you don't need?
Well, you can make better decisions if you have more data.
Then I would argue, as a leader, you need that.
You can make mostly the right decision most of the time if you have reasonable data or a snapshot of it.
But how many of you have access to every single thing you need at the snap of a finger? Okay. At Amazon, you do. At Tesla, you do. It's that simple. And it looks like this. It looks something like this, right? So this is, everybody, I don't know if you're familiar with Litmus, but if I was the machine operator, hopefully you guys can see this, but if I'm the machine operator who works on machine 1 in area 1 and site 1, in theory, what we have done is published every single event and all of its metadata into one place, so that anything that we want to do, if I want to do some machine learning application, if I want to build a visualization, if I want to just collect data and trend it over time, it is all located in one place, organized semantically. Like, we all have file shares in all of our employers, right? There's a file share, there's some D drive or F drive or G drive that you go to find all the Excel spreadsheets where people put all the data, right? Unified namespace is doing that in real time. That's what unified namespace is. Okay, why is Amazon awesome? Last foundational thing. Those of you who already know, you've been here, you've heard it before. But why is Amazon awesome? It blows my mind. Everybody here uses Amazon, right? Why are they fucking awesome? Why is Amazon awesome?
Because they already know what you're going to buy.
Convenience.
Yeah, right. You get whatever you want at the best price in 48 hours or less delivered to you. Here, for most of us, here, it's 2 hours to 24 hours, right? How do they do that? Well, they predict what you're going to buy.
Predictive analytics.
Yeah, how do they do that? They use a unified namespace. So does Tesla, by the way. So Tesla has a unified namespace infrastructure. Amazon has a unified namespace infrastructure. And what is it? It's the structure of the business and all of the events. And then we just plug people and things into it, and we consume and produce data and information back into that infrastructure. So if you're the data scientist, what do you do?
I'm an electrical engineering student.
You're a double E? Or, okay. So let's say, for the sake of argument, you decide to go study data science as a graduate student, okay? And you're going to be our ML engineer, okay? So if I'm in, is anybody here in machine learning, data science? All right. So what's the number one problem with data scientists face when it comes to data? Right. The normalizing and contextualizing, and then making sure we throw away all the garbage. Okay? Make sure we throw data. Most people will say, "Oh, we just want to do ML. We just want to do machine learning." Like, what is machine learning? Not the data scientists. What is machine learning?
Mostly training.
Yeah, it is machines. It is machines learning from data. That's machine learning. So like computers learning from data, finding patterns in data. Okay? What Amazon does is they use a software layer that sits on top of their event engine to find patterns in the data we can't see with the naked eye. And then human beings evaluate that data, and they decide which of those use cases they want to train models on. This pattern that it picked up is garbage. Doesn't mean anything. It's just spurious data. It's corollary. It doesn't mean anything. However, this is a use case, and that use case could be something like there is a pattern we see here related to the failure of late delivery for a specific product coming out of a specific distribution center. But the only way that Amazon knows to fix that problem is by using this engine that sits on top of all the events that is trying to identify those patterns. Instead of a human being somebody saying, hey, they just happened to notice in some report in the boardroom that we have an increase in late deliveries coming out of this distribution center. And I'm going to go ahead and task my my data scientist over here to go figure out the problem, right? So my data scientist goes and tries to look for the data. Okay, so the first thing he goes and walks around the distribution center. Where do you have this? Where do you have that? Where is this database? How do I access it? So he spends 4 or 5 months just trying to acquire what he thinks is what he needs. And then he realizes that the data is not normalized. So and normalization is you have to line events up, right? So if I have, a really good example would be, I have a truck ID that changes once every 90 minutes. So a truck backs into a bay, that ID changes once every 90 minutes. And I have a scanner that is scanning packages that go into that truck as a package goes in, once every 3 seconds. Well, the first thing I want to do is, if I want to find some pattern between those two, I have to have one value for each transition. So package, truck ID, package, that's normalization, okay? Amazon does that all natively. The company that asks you to take the use case that they want you to solve and have you, it'll take you a year and a half to develop a solution that doesn't work, and Amazon solved it in a week. Does anybody know how quickly Tesla built Giga Shanghai? How fast it was? From bare earth to when the first vehicle came off the line?
2 years?
If you were to guess, how long do you think it took? I got 2 years.
You know, 10 months,
How?
18 months.
9 months. Do you know how long it takes Ford to build a facility?
9 years?
8 years. From breaking ground to running their first, their plans are always 24 months, and it always takes 8. How the fuck did they do that in 9 months? Has anybody gone down to Giga Austin? Giga Austin's small. Does that surprise you? That relative to the other gigafactories, specifically Berlin, Giga Austin's small.
Lots of room to expand, though.
Yeah, lots of room to expand, which is why they're in Texas. We have lots of land, right? Exactly. 9 months. Do you know how long it takes Tesla to land a piece of equipment from the moment they say we want a piece of equipment, the day they decide they want it, to when it's running? So from spec, from the day they say we're going to start speccing this to the day it starts running, what is the length of time? What's the average lead time on a $12 million piece of equipment? 6 months, 9 months, 12 months, 18 months, 24 months? Anybody guess?
Where do they get it?
From their suppliers.
Yeah, but where are their suppliers? Are they Chinese? Are they US?
What's that?
Are they Chinese or?
Their biggest supplier is Saint-Gobain.
1 year.
6 weeks. 6 weeks. By the way, if you can't land it in 6 weeks, you're not a supplier of Teslas. Now, how the fuck do they do that? How do they do that?
Inventory.
The supplier already knows that they need the piece of equipment long before it's ever spec'd. Long before it's ever, and how do they do that?
You have access to the inventory.
Tesla requires that all of the suppliers are integrated into Tesla Warp. So they treat all of their suppliers as an extension of Tesla. So it's not a person who is a vendor rep. I don't work for Tesla and you're the vendor and I get on the phone with you and we start negotiating. When I set up the meeting for you to come in and inspect this piece of equipment, you've known for 6 months we were going to need it.
Cisco does the same thing.
Without me ever calling you, exactly. And how do they do that?
Well, they have the suppliers have access to what's happening and also access to what the sales is happening as well. So that's a good idea.
So digital transformation is a strategy, okay? It is a strategy for making data the primary commodity in any business, okay? Data is the primary commodity, not the thing we sell. It's an also-ran. The thing that we sell is the also-ran. That's not the commodity. At Tesla, Gigafactory can manufacture anything. What would they do? If they wanted to change what they manufactured and start manufacturing typewriters, how would they do that at Giga? There's only one part that's got to be changed. There's a stamp. The stamp would change. They literally built the factory to build anything. The reason they gave the patents away is so everyone would copy them. Everyone would say, we'll build Giga to do all of our manufacturing, a Giga whatever. Okay? Digital transformation is a strategy for making data the primary commodity in our business. So if we want to make data the primary commodity in our business, that is, we want to take data, convert it into information so it becomes value for the business, so that we can drive efficiency, we can lower lead times, we can do just-in-time delivery, whatever it is, then data has to become the primary commodity. Are human beings good at collecting data? No, they're terrible. They're terrible. The Japanese are the best in the world, and they can only get you about 60% fidelity. Who's the worst in the world at collecting data manually? The United States. The United States. We have less than a 25% fidelity. What does that mean? That means that if I give you a clipboard with a series of rows on it, and I tell you to collect data point at n interval, and I just send you out there for 3 months to do it, 25% of that data will be valuable. How long does it take for you to start pencil whipping? How many data points in a row? What is the rule? How many data points in a row? How many times does the temperature not need to change before you just start assuming that's the temperature? So if I asked you to collect temperature every hour, right at the top of the hour, I give you a clipboard, I ask you to collect it, and the temperature doesn't change for how many hours before you just start copying it? This is a occupational psychology question. 6. So if it doesn't change 6 times in a row, you will start, for 3 times in a row, you'll pencil whip it. About 98% of us. We're terrible at collecting data. So if someone gives you data that was collected manually, it's garbage. It is garbage. If someone gives it to you in an Excel spreadsheet, it is garbage. Garbage. The best in the world. Has anybody been to Tokyo's airport? Okay. How do the Japanese conduct themselves in the airport in Tokyo? What's the first thing you notice when there's a line of Japanese people in the airport at Tokyo? What does that line look like?
Yeah, very organized, very polite.
They're
Follow the rules.
Well,
Fucking-
it's like getting into the train, right? Everybody's in line getting in the train.
8 inches apart, standing straight up, hands to the side for miles. The Japanese are the most obedient people on the planet.
Very disciplined.
They are incredibly disciplined. And you can only rely on their data 60% of the time if they collect it manually. 0.6. This is why digital data matters so much. And if you want to collect data digitally, then you need one common infrastructure to do it on. And that's where unified namespace came from. Okay? So by the way, the goal in manufacturing, it's actually in, go ahead.
But in Marina, you can bypass that line if you have an NEC or a Badger or Nissan badge.
Oh, really? The goal of digital transformation at the end of the day is to make our business smart. And the process by which we do that is very simple. It's a very simple process. So if I work in manufacturing and I am a dumb company, dumb means I do everything manually, but I maybe have smart stuff on the plant floor, or in telecom, I have really smart switches in telecom, and they're talking, but I'm not listening. Okay? Does anybody know SNMP? Everybody knows SNMP in telecom? Okay. How many of your customers, if you're selling telecom, how many of you are actually leverage SNMP to inform ourselves about the health of our networks?
Sometimes it's not even used anymore. They use something else.
Correct.
Because it's crap.
Because it's crap. Why is it crap?
Because it was a bad protocol besides on the ground.
Because you're letting the equipment tell you itself what it thinks is happening, and it's not going to be its highest priority.
Correct. It's not the raw event. It's not the raw event itself. The thing that a data analyst would coalesce and massage into something valuable, data operations, okay? All right, so the process of digital transformation is really simple, okay? So for anybody, whether I'm in telecom or in manufacturing, the first thing I'm gonna do is become a smart business. That's 3 to 5 years. Digital transformation doesn't happen in 18 months. It takes 3 to 5 years just to become smart. Through the process of connect, collect, store, that's all the data acquisition stuff, analyze, data operations, visualize, find patterns, report, and solve. Find patterns, report, solve is the ML stuff. All that stuff happens way at the end. You have to have a massive data store. You have to have a massive data store going back into the past in order for us to learn from the past, to monitor the present, to predict the future. Okay, that's what ML and AI does. Okay, the reason that most data science applications fail in industry is because the data is garbage. That's why. It's not because data scientists don't know what they're doing. It's because the data is garbage. What industry has the most successful implementations of data science, machine learning, artificial intelligence? It's the financial industry. It's finance. Okay? Why? Right. Money is a powerful incentive to make sure that data is right. Also, the IRS doesn't forget and they don't forgive. Okay? That's why. Powerful incentives for that data to be correct. So how do they do that if it's human beings who are originally collecting it? Well, they paid 3 people to do it, 2 of them to check on the first one. Okay? That's how they did it. Okay? All right, so what is unified namespace? This is an architecture. A lot of people have asked us to go over it more in detail. It is a single source of truth for data and information. It's the structure of a business. In manufacturing, we generally use ISA 95 Part 2. So the first thing we do is we structure a unified namespace in the structure of the business. And that is generally the enterprise, all the sites, all the areas under the sites, all the production lines under the areas, and then all the cells underneath the production lines. Okay? The first thing is we create the structure. The reason we use ISA 95 Part 2 in manufacturing, in telecom there will be a different standard. There will be a different standard for organizing a telecom business. Okay? The reason we use ISA 95 Part 2 is because ERP systems, which are the system of ownership in manufacturers, they use ISA 95 Part 2 for their master data model. So if what I wanted to do was join together ERP data, which is owned by IT, and I want to put it into an event engine, I better structure it the way it's structured in ERP. Okay, so that's why generally we use ISA 95 Part 2. Okay, we actually build unified namespace. It's a single source of truth for all data and information. So here's a really good, the example I used about the truck and all the boxes coming into the truck. There would be a tag in the unified namespace that is truck ID. And the area, the line, would be the bay that it's in. So bay, then the truck ID, the truck would be in there, and that would just be truck ID. And then there would be a scan event, which is every box being scanned into the truck, and it would change as it changes, and right next to it would be the truck ID, which is not changing. That is unified namespace. Go ahead.
In logistics as well, there is a move towards that, from shipping dock, 5 packages to where it came from, all that together, cameras, all like that, similar to that.
Yes. The truth is that unified namespace, while I'm the person who coined the term unified namespace in manufacturing, and it's associated with me, when I first started doing this, I had no idea that it would become the thing that like the globe was using. Like for me, it was about making my job easier. It was like, why is it that every time I solve a problem, I connect, collect, and store the data? So I get a functional specification. I'm an engineer. I'm tasked with solving some problem. What's the first thing I do? Well, the first thing I do is I put together a solution on paper. And then I go, okay, now I got to go get the data I need in order to solve the problem, whatever it is. Let's say I'm tasked with calculating OEE, overall equipment effectiveness, or I'm tasked with creating a dashboard that's got the work order and the throughput for the shift. The first thing I have to do is figure out what data is available for me to do that stuff. And I got to connect to it, I got to collect it, and I got to store it. And I kept asking myself, why is it I'm spending 9 months of my year doing connect, collect, store? Why don't I just connect to everything, collect everything, and store everything? Why is it we're not doing that? Why don't we do it? The original reason was valid. Okay, bandwidth was limited and disk space was expensive. Is that the case today? We have unlimited bandwidth, right? Everyone agrees we have unlimited bandwidth? Okay. Disk space is cheap or is expensive? Very cheap. There's no reason why we shouldn't collect every single event. What I'm going to show you how our business is organized and how we operate with so few people, 1/4, 1/5 the number of our competitors do. I'm going to show you how we do it, how we're able to make the same business decisions, how we're able to yield 62% gross margin, how we're able to do that. And it's all about the acquisition of the data and putting it in a place we need so that we're not spending any time trying to connect, collect, and store. It's already done, okay? So the idea was to solve my own problems with unified namespace, all right? The reference architecture is basically what they look like. Is a unified namespace looks a little something like this. There's 3 types of namespaces. The red is the master model, enterprise site, area line cell. Enter in whatever. It could be anything. In manufacturers, it looks like this. And then there's essentially 4 types of namespaces, models. One is functional, so that has inputs and outputs. It's a function, just like in software. One is descriptive. Does anybody have any idea? What do you guess descriptive is? What's that? Right, it's something that basically never changes. Okay, it would be like a namespace for the motor plate on a motor, the nameplate on a motor. The serial number never changes. It gets instantiated, and then it just stays there. The in-service date never changes. It went in service one time. That's a descriptive namespace, okay? It is something that is used by other namespaces to generate information. And then descriptive and definitional are the same. Informative namespace is a consumer. So a dashboard is an informative namespace. It's all the parameters, all the attributes needed to go onto a dashboard. I'm going to show you lots of those today. It could be an endpoint. It could be an endpoint that I built that I would normally use like REST to call or SNMP. So let's say that what SNMP returns, I can build an informative namespace that contains all the parameters and the endpoints to consume. When people ask me all the time, well, how do we handle transactions? Well, you build a JSON. The payload is a JSON, right? It's really quite simple. And then ad hoc is exactly what it sounds like. It is some namespace I've created. Me personally, I've come up with it, okay? All right, let's take a look at a couple of namespaces. Let's start with this flexible packaging company. And I'm sorry that I can't zoom in, okay? So what we're looking at here is a flexible packager based here in Dallas. We're actually looking at their namespace through the Ignition platform, but Ignition is consuming the namespace. It's irrelevant. It just happens to be a node that is plugged into their ecosystem that can view the structure and the events. Okay? So the way that this is organized is.
What is Ignition and who provides the tool?
So Ignition is an IIoT platform. So an IoT platform is a platform for solving problems. Okay, think it's a IDE+++, and it's made by a company called Inductive Automation, and they're based in Northern California. Ignition's irrelevant, and any platform that is talking the protocol. In this case, we're using MQTT. So any platform that's talking MQTT will be able to see this. And I'm going to show you in a minute an example where HiByte, Ignition, and MQTT Explorer are all seeing the same thing at the exact same time. Okay. So here's how the namespace is built for them. So the enterprise is OF, that's the name of the company, and then the Dallas location, and then we've broken their facility out into all their areas. I'm going to give you a overhead view of their plant. All right. So what we're looking at here is in the lower left-hand corner. What these guys do is they print flexible packaging for like Coca-Cola, right? If you buy a case of Coke, it's using like a laminated shrink wrap. They print that. They also print the stuff that goes in Doritos bags. So when you look at a Doritos bag, that's what these guys make. Okay. But they either make just the film or they make the bags itself. All right. So they have a printing area. They have 4 printing presses. They have 5 of them now. These are each about 25 million, and they're all high-end Siemens motion control. They have lamination area over here, and the lamination area is after the film is printed, it goes to lamination to give it a film on top of it. Then it either goes to the slitter. Over here, there's maybe 10 slitters, and then there's a bag machine, a pouch machine where they make the actual bags. All right. This facility, when we first started working with them, they were doing 25 million in revenue annually, and now they've doubled it. They've doubled it by adding 1 press, and they've doubled it by what we built here. And they spent basically nothing, relatively speaking. They got almost a 50x return on their investment in 18 months. All right, so that's what the plant looks like. This is what their namespace looks like. So bag area, we're going to go ahead and take a look at their presses. So what we've done is we've built a unified namespace with our functional, informative, and descriptive namespaces underneath each of the assets. Okay? And here we have production line with lots and lots of data. Okay? Here's what it looks like to them. Everything you see on the screen comes from the unified namespace. So when we first started with this client, they had like an office that had a big like a metal board on the wall, and all it had was these little tickets. It looked just like that, little white pieces of paper. They were printed, and they had them. They literally had it on this metal board, and like people would come in, and everywhere, you know, the plate maker would come in and he would initial, hey, the plates are made for this work order. What we're looking at here is the schedule. And for each number you see here, that's a work order. It's a production run that must be done on the press. The press is the bottleneck in their facility. So 118971 is a row inside of a data set that's living inside the unified namespace. So when they check in 118971, when they scan it, the production line starts running, and that work order is scanned in. All of the events on the edge, so every time the in-feed changes, that is every time they're unwinding the film that's going into the printing press, that we're able to collect that data relative to the work order that's been scanned digitally. And everything gets stored in a back end, and then we can analyze it later. Okay? This is what a unified namespace looks like, and this is how you build visualizations. This is what the visualizations look like. Everything that's on the screen comes from the structure and the events. How is software generally made? Anybody here write software? All right, so software, for those of you who don't know how software is made, there's back-end API UI. That's how it works. There's a back-end, there's a data store, and the data store has the master data model. That is, what will this application look like? It may store the CSS that shows you, that tells you how to build the visualization. Then there's an API. It's the way that the UI talks to the back end to get the data it needs to put on your app, on your phone. All software is built exactly the same way, back end API UI. What we've done here, unified namespace, is the back end and the API in one common technology. One common technology. All right, so let's look at why that's valuable. Obviously, building visualization is one piece of it. But imagine I'm the data scientist who's now tasked with modeling the relationship between a work order running on a printing press and the amount of waste that's generated from that work order. Right? I want to try and predict the amount of waste that's going to happen on a specific work order. If I tasked you with that, let's say you're a data scientist, right? All right, so I say to you, your job, I just hired you, okay? I'm gonna pay you $250,000 a year, and what I want you to do is give me 99% reliability on predicting how much waste is gonna be generated on any work order. And it better be 99% accurate. And you got 24 months, right? By the way, this happens, okay? What's the process you would go through? If I hired you to do that, you'd go, okay, great. Walk us through the steps. Walk us through.
You look for your measurements, like you said, connect, collect, store, and then you start looking for, okay, what am I being measured on? Waste? What kind of waste? What characteristics of the waste? What characteristics of the work orders? What's the characteristics of, what data am I missing? And then literally just start stitching it together and try to find the right patterns.
And for the most part, that data doesn't exist. For the most part, it's on some piece of paper somewhere. A characteristic that he would need is the film type that we're printing on. The only thing the work order is going to connect us to is the bill of materials, and the bill of materials is going to give us the film type. Another characteristic will be the vendor who created the film for us.
Humidity of the factory floor.
The relative humidity, the temperature inside the oven. The operator, exactly, the time of day, what time during the shift. Hey, newsflash. Not every minute of a production shift is not created equal. For example, the 15 minutes before break you definitely underperform in the 15 minutes before and after a break than you do at the 2-hour mark in between breaks. Okay, what is the most productive day of the week? Which 2 days should you never buy a car? When a car was manufactured, what are the 2 days you're supposed to look inside the door? You're supposed to see the manufacturing date. Then you're supposed to go look at what day that was. What are the 2 days you are never supposed to buy? Ever. Monday and Friday. Why? What's the day you're looking for? Wednesday. You want the car made on Wednesday. By the way, those are characteristics that he would need in order to be able to predict the quality of a vehicle, okay, digitally. By the way, this is very, very hard. It is not easy. It's really hard. Just getting the data you need, right? Unified namespace is all. I started the whole conversation with how many of you have access to everything you need, and the answer is none of you. There was a caveat, need or want. The truth is if you want it, you need it. Right? If you want it, you need it. You didn't want it for no reason. You're willing to do without it, but you need it, right? This architecture is about that, all right? So let's take a look at raw, how it looks. All right, so is everybody familiar with MQTT? All right, so MQTT is irrelevant. That is it's just broker technology, messaging, queue, transport, telemetry. All of you are experienced with MQTT because if you use iMessage on your Apple phones, that's transmitted over MQTT. When someone's texting you and you see the ellipses, they're typing, they're using MQTT. That's because it is a stateful, edge-driven protocol. In the old days, when we sent a text message, why didn't we see the little ellipses?
Best delivery, best chance, best what was the word? There was no guarantee.
Right, you guys were all in telecom, right? So in the old days, when we were text messaging, why is it we didn't see little ellipses when someone was typing?
Because nothing left your phone until they hit send.
Correct. Until they hit send, it went to a server. You were the client, and you would check at n interval, whatever interval was, do I have something in the queue for me? That's not how edge-driven technology works. Messaging, queue, transport, telemetry, MQTT, other protocols like DNP3, AMQP, which was developed by Microsoft, they are very similar. What it is that I'm a broker, okay, and you guys are all publishers and subscribers. And my job is to keep track of everybody who has published information to me in a hierarchy. So this is digital transformation / phase, and the payload, see right here? That is the topic, and the payload is 5. So you are responsible for digital transformation / phase. You're the one who's telling us what phase we are in. You are going to publish to digital transformation / phase what phase we are in. We are in phase 1 through 6. And every 30 minutes, you're gonna toggle our phase from 1 to 2 to 3 to 4 to 5. And what I'm gonna do is you guys are gonna subscribe. You might subscribe to digital transformation / phase. My job, you're gonna push it to me. My job is to notify the person who subscribed to that topic when it changed, instead of him checking at n interval for it. And I normally use a marker example here. If you want to know like the difference between the most digitally advanced companies in the world and the ones who are not digitally advanced, there's only 2 attributes. Well, actually, there's 3. Attribute number 1 is that the most digitally advanced are led by technologists who are transformative and disruptive leaders. Elon Musk, okay? Jeff Bezos, the CEO of Volkswagen. Can't remember his name. Okay? Does anybody know? Look up the CEO of Volkswagen, because I want to give him his due.
North America or
The full CEO. He's an engineer, mechanical engineer. Does anybody know who the CEO of Ford is?
It's not the same sport, right?
No, his name's Jim Farley. He's actually he's the cousin of Chris Farley, the comedian. Does anybody know what Jim Farley's?
By the way.
What is it?
Oliver Bloom.
Oliver Bloom. Okay, Oliver Bloom runs Volkswagen. He is an engineer. He's a technologist. He also happens to be a transformative and disruptive leader. Do you guys know what those transformative and disruptive? All right, so who here has worked with Toyota? Any experience with Toyota? All right, what is Toyota's mantra about the way they operate? They call it.
Business system, the Kaizen,
Yeah.
continuous improvement.
They say people first, right? People first. No, fuck that. All right, that's how you know Toyota will not make it. You cannot prioritize people who, does everybody know Purnell's iron law of bureaucracy? Shirky principle? What, does anybody know what those are when I say that? Okay, Purnell's iron law of bureaucracy says that as an organization grows bigger, it creates sub-entities, divisions, groups, small groups, big groups. Purnell's iron law of bureaucracy says that as that company ages, what becomes the sole purpose of each of the sub-entities?
To continue to survive.
To justify their own existence. That's Purnell's iron law of bureaucracy. It takes a transformative and disruptive leader to break those things apart. Toyota says we are people first. So what does that mean? I can't disrupt and I can't transform. I cannot disrupt and I can't transform. Is there any situation at Toyota where you are allowed to tell someone to their face they are wrong? You can, using these words, you are wrong.
Oh, no.
You are not allowed to do that.
Especially if they're above you, you probably.
No. It is grounds for you will be terminated if you tell someone at Toyota to their face, you are wrong.
Your peer?
Anybody. Go ahead.
One of the Japanese traits is when you're saying no to somebody, they want to say a face for the person they're saying no to, which translates to what you're saying. You can't say that, but there's another way to say it. In agreement, and then switch to what you want to do.
So the 3 attributes of the transformative organization is the digitally advanced. They have transformative and disruptive leadership. You know, look at all the hate Elon Musk gets. Like, look at all the hate he gets. Like, does everybody agree he's not a popular guy in the United States? Does the media obviously doesn't like him. Why is that?
Well, most of it is his doing, but
No, it's not a conversation for a different time. It's an important conversation. Right? If you are in this room and you believe that Elon Musk is part of the problem, you're going nowhere in digital transformation. You're going nowhere. Let me say it again, because I know I pissed some people off with that. If you believe Elon Musk is part of the problem, you are going nowhere. And I could prove that empirically.
part of the problem of what?
What's that?
Part of the problem of what? In what area?
Part of the problem.
We have to decouple what he has done, what he has presumably done with Tesla, with what he's doing on social media, and those two are not the same.
public persona is very important.
I'll tell you this. Elon is smarter than all of us in this room put together. And he's playing 5D chess. The rest of us are playing checkers. There is nothing Elon Musk said. Let me say this again. There is nothing he says that he doesn't say for a explicit purpose. Is everybody here familiar with conflict theory? What is conflict theory? If you're familiar, what is conflict theory?
Isn't it using emotion to generate a certain type of response?
Right. You're using emotion. You're intentionally picking the scab to get a specific response. Why?
So that
Why would you do that?
an authentic reaction.
What's that?
It's easier.
It isn't easier.
It's predictable.
No, what it is you've read How to Win Friends and Influence People. Okay?
Setting up the next step.
Right. If all I have to do to beat you is to piss you off. That's it. Up until the moment I get you emotional, you have a strategic advantage because you have studied how to manipulate people in polite conversation. You've studied it. But the moment I get you angry, I have the advantage. Elon knows that everybody at Tesla has read How to Win Friends and Influence People. He knows that everyone's read it. He knows everyone has read Good to Great. He's read them too, but the only reason he reads them is to figure out who else read them. He's playing 5D chess. He's playing everybody. Look at what Elon has done as a transformative and disruptive leader. SpaceX. How cheaper is it for SpaceX to launch a rocket than it was for NASA 30 years ago? It will blow your fucking mind.
Probably more than 100 times.
Way more than 100 times cheaper. Keep going. Keep going.
Well, it's not even a comparison.
It's 10,000 times cheaper now. It was 1,000 3 years ago. 10,000 times cheaper. How many fewer people does he use?
Well, that's not the only thing. He's got an automatic docking system that also is far ahead of everything else.
The point is this. Here's my point. My point is that how many total employees does he lead? 150, 160,000 total, globally. 150, 160,000. Why do you think he does what he does? He does it for the same reason I do it. I learned it from him. We'll go back to the 100% inbound. The reason I use fuck in a speaking here is because if it offends you, you're not going to talk to me. You're going to go, oh, this guy is so arrogant, whatever. I'm doing it all on purpose. I'm doing it all on purpose. But if it resonates, if what I'm saying to you resonates, the 3 or 4 of you who go, you know what, man, he really gets it. Shannon's like, yeah, he really gets it. Shannon calls me later. He says he's one of the only guys in the room who gets it. That's what transformative and disruptive leaders do. Number two, the digitally advanced companies in the world, they use edge-driven, report by exception, lightweight technology. The least advanced use server-client relationship. Server-client is poll response, and brokers are edge-driven. If you look at the vast majority, and you're a tech guy, the vast majority of infrastructures in the United States or globally in manufacturing, they are server-client. They're poll response. Okay? And then the last thing is data is the primary commodity. Okay? All right, let's take a look at how my company uses unified namespace. So I have 2 companies here in the same architecture, right? Every single data point I care about is in that screen, is in this event hub. Everything. There's not a single data point. We use Zoho for our CRM. We use Stripe for our payment system. What other systems we use externally? Zoho, Stripe. We use Zapier for automations. We use a TMS system that we built internally. All of them are integrated together into one architecture. So if I look at 4.0 solutions, we have this Opta Wi-Fi. I just wanted to show you something. That 4.0 solutions has an Arduino Opta running in our environment that is publishing into the same infrastructure that our business data is in, okay? So if I look at IoT.University and I look at my KPIs and I look at April of 2024, my daily sales average for this month is $5,579. We've done $22,000 in sales in the last 4 days. We've had 17 total transactions, and our transaction average is 1312. That is in the same namespace as all of the operations for our engineering, which contains all of our open, I can't show you that part because our NDAs, but our dashboard here. So this is open accounts, open hours, everything. All in one infrastructure. So if I went to a data scientist and I said I wanted to see the relationship between the leads that come in, the rising edge of the leads that come in my education and outreach arm, 4.0 Solutions, which is a completely separate company. I want to see the relationship between the number of leads per day and the sales per month at my engineering firm. All of the data you need, connect, collect, store, is based inside the unified namespace. And it is accessible by any other open technology. So if we look here, let's talk about HiByte. So HiByte has this is a completely different tool and a server running in the cloud, completely independent. You guys will notice enterprise. This should look familiar to you. It is the same namespace that's being used in a completely separate architecture. HiByte, which is the tool he represents, just plugs into the infrastructure, and now I can do data operations on any event in the business. I no longer am I saying, give me the reference architecture that shows me all the databases, give me the DBA who's in charge of the schema, what's the relationship between customer and sale? It is all in context. Go ahead.
Walker, are you addressing only manufacturing, or are you across industries in other areas where some of the processes are not that dissimilar?
Yeah, so unified namespace is not unique to manufacturing. So I own a company called FullStrength.ai. Actually, I was going to wear the t-shirt. We took some technology that we developed, hired us to use vision technology to predict repetitive use injuries. Okay, so they had a process in manufacturing where operators kept getting hurt on this one process. They had what is the robot that assists human beings? So it's the one where the human works with the robot. They take a door, cobot, there you go. And they take the door and they swing the door onto a car and they hold it as a robot welds it over and over and over again in my station. And they kept getting these repetitive use injuries on that process. It would be a hip injury. And they did not understand what the actual problem was. They knew it was like a pivot problem, but what was the actual problem? They spent millions of dollars in man hours. 6 different people they had from multiple angles just observing the operators over and over again. They filmed them. They spent millions of dollars trying to save tens of millions of dollars on repetitive use injury. We developed a vision technology that did pose estimation that turned the movement, the human movement, into a digital artifact, basically plotted it on a chart. And it only took us one injury to figure out what the problem was, and it was this one operator. Everybody was pivoting on their toe, and she was pivoting on her heel. That was it. If you pivot on your heel, you're going to get the hip injury. If you pivot on your toe, you weren't. Well, how did we figure that out? Well, the answer was the human being couldn't see the gap under the shoe because there was no gap. What you had to look at was the angle between the knee and the toe. And only a digital artifact could see that. What did we do? We took that technology and we used it to predict 1 rep max in weightlifting. So I went to Rogue Fitness. If you guys are into fitness at all, Rogue is a big fitness company based in Columbus, Ohio. I called Brian Shaw, who's the 4 times world's strongest man, and we said, hey, we want to collect data off of these athletes while they're doing a deadlift using this technology we did with Toyota. And we used a unified namespace to transmit the data from the athletes to Rogue Fitness in real time. There are unlimited applications. I went to a concert the other day, a couple weeks ago. Brandon Lake, he's a contemporary Christian artist. And he gave When we went in, everybody got a wristband, and that wristband glowed. He gave everybody a wristband. The way most concerts do that is when they'll basically just use a signal to the wristbands, and everybody's wristband will be the same color. So it'll be red, blue, white, whatever. Have you ever been to a concert that does this? Okay, all right. They didn't do this. What they did was they wanted to do color across the whole audience. So they wanted to like create a wave. And then they wanted the right side to be red and the left side to be blue. And they wanted the back to be white and they wanted the front to be red. Well, how would you do that? Because people are going to go to the bathroom. Moreover, you don't know, you're just taking a wristband out of a box. They don't know what seat you're sitting in. So what did they do? They were using real-time location systems from the band, and they were placing everybody in a unified namespace, and then they ran the code based on where our location was. They weren't using geolocation. They were using real-time location systems for it. And they used the unified namespace. I asked the engineer, how'd you do it? And he showed me. He said, look, there's a human being, and we have red and blue. We broke everybody up based on their location, their actual location in real time. So yes, the application is unlimited. All right, with that, how long? I didn't go too long, did I? 10 minutes over?
Yeah, you're an hour. 5 minutes.
Okay, all right, questions? Go ahead.
Yeah, with unified namespace, you kind of utilize things like MQTT broker. How do you address single points of failure with everything covered in one place?
So it depends on where that failure point is. It's a good question. How do you address single points of failure? So we have what's known as horizontal and vertical redundancy, right? So with the brokers horizontally, we basically have copies of brokers, right? We can either do that in clustering or we can do that in what's known as transmission, where I can transmit the full namespace from one broker to another, and we just copy horizontally, and then we can do the same thing vertically. But from the nodes themselves, you're a node, you're a node, you're a node, what we're doing is we're putting on store and forward on each individual node. So say the connection between the node, because it's a stateful connection, you will hold on to each of those publishes, and when we reconnect, you will send them in order to me with the timestamp of the event. So you will go in order. That's a beauty. One of the beauties of broker technology is the timestamp is not controlled by the broker. It's controlled by the node that sent the publish. So if something happened at 10 o'clock, 10 o'clock, the temperature was changed to 100, and we're disconnected, and it's changing 60 times per second, at 60 hertz, you're able to send me those exact transmissions as they happened in order once we've reestablished using store and forward. Yeah, MQTT by nature is stateful.
Yes.
So there is a MQTT 5 is there is a birth certificate and a death certificate.
Yeah, so basically I was going to mention that. So that's really practical when you're using something like MQTT, where you can set like retention true or something like
Right.
that. But
Retain or quality of service 2. So that is so. This is the technical stuff on MQTT. And by the way, this is not an MQTT discussion. One of the things that I've been having to do is explain unified namespace and MQTT are completely separate elements. It just so happens that when you are building a unified namespace, a digital infrastructure on UNS, 90% of the time it's MQTT.
Because it's hierarchical, make sure it pops up fashion.
Right. It just works. But the architecture of unified namespace is not dependent upon MQTT.
Easiest to implement quickly.
Right, it just happens to be the one that works the best right now. And by the way, if you want to know more about this, I'm actually looking for that LinkedIn post. I want to show you. I want to go through that last. On April 12th, so Arlen Nipper, who is the co-inventor of MQTT, we're doing a mastermind session for Litmus automation. So we'll be teaching how to use Litmus with unified namespace on Friday, April 12th. But the third hour, we're going to be doing an interview with Arlen Nipper. So it's going to be myself, Aaron Semley from your company. Aaron Semley is the CTO of HiByte. I didn't know that someone from HiByte would be here, by the way. Matt Paris, who is at GE Hire. He is the digital architect there. And myself and Arlen Nipper are going to have a conversation about MQTT the spark plug specification and the future of the MQTT and spark plug specification. Why? Why are we going to have that conversation? This post from Andreas Vogler. Okay, this is just one. This happened today actually, but what most organizations have tried to do up to this point to create digital infrastructure is to go to a standards body and say, write us a standard. Write us a standard for how we build our digital infrastructure. Okay? Did Tesla go to a standards body? No. Did Amazon go to a standards body? No. Who goes to a standards body? Companies that are not led by transformative and disruptive leaders, who are technologists. Okay, because it only takes a moment. Those of you who are familiar with the OPC standard, OPC UA, if you actually read the standard and you know anything about data operations, it is very easy to see why it is OPC UA is not widely adopted all across the world. There are millions of devices that have OPC on board. But the way the specification is written, just because you have OPC on board and you have OPC on board on your product does not mean they talk to each other. Because the spec is 90% optional. So if you implement a part of the specification that he needs, 90% of which, there's a 90% likelihood that you implemented something, you didn't implement something he needed. Because you only implemented the part of the specification that you needed. Okay? But Andreas Vogler, this is an important conversation. Andreas Vogler, this is the kind of thing that happens all the time. He said, hey, OPC UA pub sub, that's using the OPC standard with MQTT. Is there something wrong with the reference publisher? Basically, real simple. He wants to write an MQTT, an OPC client that's going to send data over MQTT to an OPC server using C#. Okay, that's what he wants to do. Okay, and he ran into a problem. He says, I tried to use the C# reference implementation of OPC UA pub sub. At startup, the console publisher publishes 2 metadata messages. So metadata is stuff that goes with data. It gives context to data. It sends 2 messages, one for the dataset writer and one for dataset writer 2, but on a single retained topic. So the specification says we have a topic that we're going to publish 2 different messages to in order. Okay? So when we connect, we're going to publish this metadata first and this metadata second. What is the problem with that? Right. If I'm not connected, I won't, and I connect after the second message was sent, I only get the second message. I only get the second piece of metadata. Now, I already knew that was the case, which is why we don't use part 14 of OPC. And you don't have to know OPC to understand any of this. What you need to understand is that the standards bodies can't get out of their own way. That's the reason no one's using the standardized infrastructure that the OPC Foundation has written. It's not just them, it's ISA, it's all the standards bodies. Because they don't work in manufacturing, because they don't build these solutions, most of them are joining these, who joins the standards body?
Largely it's the bigger companies.
Yeah, who joins the standards body? It's the big company. And why? Because they want to push the standard in the direction that will sell their product. So he calls out for help, and guess who he tags? Eric Barnstedt. Does anybody know who Eric Barnstedt is? Eric Barnstedt's the guy who's responsible for the 10,000 people who got laid off at Microsoft in Microsoft IoT. He is the global architect of Azure IoT. Okay? The reason he tagged him is because Eric sits on that standards body, which is the reason Eric didn't get fired. Okay? This doesn't work. And I wrote a scathing response. Okay? A scathing response. You just found one of the many limitations of Part 14, and the follow-up is one of the reasons that Tesla and Amazon and other companies don't use these standards. Okay? The reality is, when it comes to digital transformation and infrastructure, companies build their infrastructure, their data infrastructure. Okay? Tesla, Amazon, everyone. And unified namespace is the way that they're generally doing it. Okay? Any other questions before you guys go around the room and do your thing? Yeah.
I guess I kind of have a more sort of general question, right? It seems like basically building this on MQTTs works pretty well if you're able to collect the data yourself, right? Or in the sense that basically you control how the data is collected and you have control over that edge system, right? How do you deal with basically like ERP systems that are inherently designed to be closed so that the data is captive in those systems, right? And how do you get it to be sort of more available in a framework like this?
So there's three elements. There's architecture, which we design. We basically base it on unified namespace. There is strategy, digital strategy. What do we want to do with our data? Why do we want to be a digital company? And the third thing is minimum technical requirements. So what we do is we write minimum technical requirements for the ERP vendor. So when I'm gonna, and I give that minimum technical requirements, we call them MTR, to the ERP vendor. And what we say is, you have to, if you don't support our technology natively, to expose the data that we need, primarily bill of materials, work order, that kind of stuff, then you have to build a gateway that will transform it from your native structure into ours. And that MTR goes into the specification with the vendor. Okay, and it's not just ERP, it's also your machine builder. Like, I mean, anybody who does machine building, say you do data centers, you're always specifying the function you want, but you're never specifying where you want the data to go. No one ever asks the question, how does this plug into what I already have? Right? Minimum technical requirements says it must plug into what I already have. And it's got to be formatted, it has to use this protocol, and it's got to be formatted in this way, ISA 95 Part 2, with functional, right.
Doesn't that require whatever you're designing to be for like a really big company, because otherwise they won't care?
Say that again?
So I mean, that's like, it could be a big lift. So let's say you're talking to, Oracle or somebody like that, right, with their ERP solution,
Yep.
right? Unless you're showing them a suitcase full of money, they're not going to care about what you want or your technical specification.
So there's a second piece here, okay? And why is it everyone's scared? Why did they write Gartner? I mean, for years, Gartner said unified namespace is not the architecture to use, and then they wrote a paper last year saying, yes, it is. Why? Well, because Tesla last year, the Model Y was the best-selling car on the planet. And Tesla doesn't use Oracle or SAP or Tesla built their own ERP system. And then what they said was, hey, Saint-Gobain, by the way, Saint-Gobain is bigger than Tesla is. And Tesla went to Saint-Gobain and said, you're going to be our supplier. You're going to support our infrastructure. And it's not just Saint-Gobain. It's every single supplier. And yet, you know what they all said? Yes, sir. You got it. At the end of the day, it only matters that Amazon and Tesla do this. It only matters that Amazon, Tesla, Volkswagen do this. And now Mercedes and BMW.